Hello everyone, we will solve this today's LeetCode problem. This is find the maximum sum of node values. I have already made this video on this, but unfortunately the video don't get upload and it got crashed and the video don't the video is not able to upload on there. So I need to make another video. So here's all written all the steps which we have covered in my previous one. So I will take help of this and explain you all, right? So let's see what the question is. So we have an exist and undirected tree with n nodes number 0 to n minus 1, and we have given a 0 index 2D integer array of length n minus 1 where ages I indicates that there is an age between nodes u and vi. You are also given a positive integer k and 0 indexed array of non-negative integer nums of length n, where num side represents the value of the node number I. Okay. So we have given a tree, undirected tree, and all the values of that tree nodes it is represented in the this nums array, right? Value of the node numbered I is represented in nums array. So Alice wants to sum of the values in the tree nodes to be maximum, for which Alice can perform the following operation any number of times on the tree. We need to choose two nodes and update the values to num0 to zord k and nums v to zord k. Okay. So we have given a zord k, and so we need to operate on any two node to on any edge which have two nodes to zord k and zord k, right? So this is how we need to find the maximum possible sum of the values after achieving by performing the operation any number of times, right? So Alice need to maximum this maximum possible sum of the all the values by performing this zor operation on any edge, right? So if you see example 0, 1 and 2, in this 0 value is 1, 1 value is 2, 2 value is 1, right? And k is given as 3. So for now the maximum value value is 2 plus 1 is 3 is equals to 4. But we can take any edge and take a XOR of both of the nodes value to any of the two nodes. So if I take 0 and 2, it means 1 and this one. So 1 XOR k is, if you see here, 0 is 1, 1 XOR 3 is 2, and this 2 XOR 3 is this 1 XOR this 2th node value is 1. So 1 XOR 1 is 1 XOR 3 is 2 again. So if I take the edge between 0 and 2 and take a XOR with k, it gives us 2 and 2. So the total value which is comes 2 plus 2 plus 2 is 6, because this is already 2, and after taking XOR it becomes 2 plus 2 is 6, right? So if I take another edge 0 and 1, so this is 1 and 3, so it becomes 2, and 2 becomes 2 or 3 is 1, so it becomes 3. So after adding 2 plus 1 is equals to 4, so maximum value is 6 here, right? So we can take any edge and take a XOR of both of the nodes which are connecting on that edge, so that I can find the maximum possible value. That is the question, right? So we are we will focus on this XOR value. So what are the some XOR properties we have? So if you XOR with any number with 0, it will gives us b, right? So these four properties you should remember by heart, right? So if you take a XOR with itself, it means it will neglect both of the values if the both values same, so it will gives us 0. Again, if the both of the values is not same, it will gives us 1, and if it is same, then it will gives us 0, right? So these four properties you should remember, and we will use these properties in this question to solve, right? So this is very tricky problem. While making the video, I was very happy for after solving this, right? So you will be also get happy after this implementation part, right? So we need to anyhow use these XOR properties after this. So I need to choose a pair and take XOR on both of the values, right? So if you see, if I take any example, suppose this is a tree, this is a single large tree a b c d e, right? So if I suppose I take this edge a b, so I need to take a XOR of this a XOR k and b XOR k, right? I need to take a XOR of k, right? A XOR k and B XOR k, right? Now suppose I choose B and C again, then what this will happen? This will become B XOR k, and this will become C XOR k. This will become C XOR k when we want to this. But if you see here, this k XOR k will neglect both of this and will return 0, and B XOR 0 will become B. This is the same property, first and the second property, right? Again, if you take this edge and again want to take a XOR of this will give us C, and this will D XOR k, right? And now again, if you take this edge, this will again D XOR k, which will give D, and E XOR k is here. So if you see here, if you observe here, that we can take any nodes, B to D, B to E, C to E, A to B, C, A to D, because in between, by taking any edge again and again, XOR, this B becomes B again and C becomes C again, because it get propagating from A to D, because we can move in any number of times now. So after taking this A, it becomes A XOR k, and this becomes B XOR k. Again taking this A, it becomes B XOR k XOR k, which ultimately becomes B, and this becomes C XOR k. So this A and this C get changes, but B is not get affected, right? And we are following these steps by we are choosing any edge and doing this step. So if you observe here, what we do, we can choose any pair of two nodes in a tree, because the tree in tree, this is undirected tree given. It means all the nodes are connected by a path. So we can, all the nodes is connected, so that so I can reach to any node from any node simply, right? So what we can do, we can choose any pair of nodes to find the to take a XOR on both of the values, right? This is the simple way I can do this. So is this tree needed now? Because I need two values. It will take if this tree is not needed now, because I can take any two nodes, right? Because so I don't need to traverse on tree again, because I need only this nums array, which has the values in it. Now now this problems concluded to array only. Now this problem concluded to this array only nums, right? This tree question is concluded to array only, because now a tree is not needed. So I don't need to focus on tree. Now I will focus on array part, because I can choose any two pair of nodes and and do on operations like this, take XOR on this and find the value, right? Now the focus is on that the focus is on that I need to take a pair of nodes and mm, make them a max value, right? Okay. Now the thing is here, that this problem changes to array, right? So we will use the num array for solution. So I will choose any pair of nodes and change the value to vals or k. I can change that, because that's the operation we need. So don't you think that this vals or k will I will change this value to vals or k only when this vals or k after operation is greater than this value? Then I will get the maximum possible sum na. If this is not considered, then why will I make operations on that, right? Are you with me, right? So suppose I have chosen two pair, and both of the values after taking XOR will give me a positive value, means will give me a greater than value than existing. It means then I have some benefit of choosing to at both pair na, right? So what will I do? Take I will take all the values. I will take, okay, let's remove this. So what will I do? I will take all the values, all the differences values which we need. Suppose all the differences value. What mean by differences here? After taking XOR minus val. If it is I will store all these values in my I will store all these values in another vector. Why? This is the difference. This is the difference. So is if this difference is with any other value, difference is positive. If this both summation is positive, it means I have definitely greater than this value, which is the val and this val one. Why I'm saying that? Because after minus this, and after minus this, after minusing, after difference of this, is this tells me that is this a post if this values or k is greater than this value or less than this value, right? This tells me that. And if this tells me that that value is after this is greater than this or less than this. If you see the value is the why I'm taking difference to see that whether this vals or k is greater than this value or not, and this val 1 or k is greater than minus value or suppose this gets negative and this is positive, but ultimately both are positive. So I need to take a pair. So by taking a pair, I'm not sure that either if both of the summation is positive, then I am sure that this will give me the values greater than the previous values. I'm for sure this is correct, right? So if this is greater than, then I can take this pair, right? I can take this pair. So I will simply store all the values like this, all the differences of the values or k minus value in my array, and and take the number of counts. So if the number of counts of all the values of all this type of values is even, is even, then I can make pairs. I can make pairs because this is even, so I can make pairs because this is divisible by 2. So I can take all the values. I can take all the values now. If the summation all the values whose pair difference is, whose pair is greater than 0, pair summation is greater than 0, right? I can take all that. If this value summation is greater than 0, I can take all that even summation. But when it is odd, when it is odd, what I can do is, but it is odd when it is odd, I will left one, I will left last value, last value. So what will be the left last value? It should be the minimum value which I left. It should be the minimum value. So how we will determine this minimum value? So what we are doing, we will just, so suppose we will just store all the differences value in a vector and sort it in decreasing order. Why we are sorting it? So suppose a b c d f g is given, and a's or k, b's or k, c's or k is all the values, and a's or k minus a is value 1 and b's or k minus b is value 2. So I'm storing value 1, value 2, and value 3, value 4, so on, like this for all the values. So if suppose there is an odd values, so I can't make pairs with the last element. So the last element should be left out. So the last element should be the least possible value because I need a maximum possible sum. So the last value which we left should be the least possible. So how we will determine it? We will sort decreasing order. So it, that's how the last element would be the least minimum possible. I'm confirm. So I will just left out the last one, right? So what will ultimately we do? We will ultimately do what we'll do. We will move in array nums because this tree is not needed anymore. We will operate on this nums only, and we do this. We will move in array nums and store all the difference value in any array and sort in array and sort it in decreasing order, right? And this is something. This is the thing. And if the count of this array is count of this array is even, then we will take all the, then we will take all the pairs which has summation value greater than 0, greater than 0. And if it is odd, then the last element will be left out. The last element, we left the last element. We will left the last element, right? We will left the last element, right? So this is how we will solve this. So the implementation part is, I have already made the video on this, so I've already implemented this. So let's we will move to its code part. So if you see here in this, what we have done, we are this is long run, so I have make a macros of this, right? So this answer will store my total number of maximum possible sum. So initially, what I need to do, I need to take a value num psi k, and I will store the difference of this value after taking XOR and the current value. Okay, and after this, I need to or I will what I am doing. I am just sorted in decreasing order, so that first I will get a maximum changes. So first I will get the maximum values which I can get after sorting, and the least element would be at last, because if the total number of total number of elements is odd, total numbers of elements is odd, so that I can left the last element. So now if you see, while iterating, I have written and modulus 2 here. Why? Because this and modulus 2 will give me 1 or 0, depends on odd and even. So if it is odd, it will iterate till n minus 1 less than n minus 1, and if it is even, it will iterate less than n. And now I will check for each and every pair, that if the summation is greater than 0, then I will include in this my answer. Okay, so this and this should be confusing, so let's analyze this. I have already written it here in my previous videos. So let's see. Suppose ABCDF is a node in a nums, right? So what I'm storing, I'm storing the XOR value minus num psi, this part, right? This part, the whole part. And initially I'm also storing the num psi which was the present before operations. So I was storing ABCDF in all in my answer here, right? So if the summation is greater than 0, suppose this part, this is greater than 0, I'm adding this in my this initial array. So this A and this B is will neglect this AB, so it will left out with A's or K and B's or K. So let's use this here. So let's use this here, that this will left out with A plus B and A plus B, A XOR K plus B XOR K instead of AB, right? And that's what we need. And the values which is less than 0, suppose this C is or K minus C and D is or K minus D, summation is less than 0. So if I don't add this values in my answer, so this C plus D is already added in my answer, so it will not be affected, and I need C plus D if I don't do operation on this, right? So this is how we will adding this. So initially I have added all the ABCDF in my answer, and now I am adding A is or K minus K, B is or K minus B, depending on whether this is greater than 0 or not. And this is how we will get return answer, right? So this, if you see how we will move from tree part to array part, right? So this is how we will find. So what will the time complexity of this problem? So the time complexity will be O of n log n. Why? Because in this we have stored all the differences in array and sorted, so that takes O of n log n. And the space complexity will be, because I have taken an extra array, so the space complexity will be O of n, right? Now this is O of n log n and O of n. So can we do it in O of n, and can we reduce the space complexity also? So let's see what we are doing. Taking we are taking the difference value, we are taking the difference value after operations, and depends on number of counts of even and odd, we are removing one last element or taking all the values. And when we are taking all the values, when the summation is greater than 0, when the summation is greater than 0, right? Okay, so the one thing is clear, that we will only include the values which is greater than 0 part, right? We'll only include the value which is greater than 0 part. So, and if and also the one thing is clear, that if the total number of counts is even, so we will include all the positive values in it, right? So instead of this sorting value, if I use only a variable part to find the last element, which may be neglected if the total number of counts is odd. So can we do that? Let's see. So suppose uh, I take abcd part, abcd part, right? I take abcd part here, and I take a XOR of all this, right? I take a XOR of all this. So suppose there are five elements, right? And I take XOR of all this, and a is or k minus a is greater than 0, b is or k minus b greater than 0, c is or k minus c is greater than 0, but d is or d minus less than 0, and e is or k minus is less than 0. So if this change is greater than 0, that I can show that can be this may be possible in my answer, because it is the greater than 0, and we know that I need to take a pair. So I need to make a pair, I need to take a positive values. I need to take a positive values, because negative values will decrease the possible sum, right? So why will I after taking XOR, if the value get decreased, then why will I take that pair value, right? If the values after taking XOR get decreases, then why will I take a pair that? So I will take only the pair which will increase my value after taking XOR. Then I'm sure that this greater than 0 will be a part of that, right? So suppose uh, if the difference so suppose if the difference of all the positive if the difference of all difference is positive. So let's forget this. Let's forget this. Let's do this from starting. So suppose all the values are positive. Suppose all the values are positive. This is all positive. Suppose this all are positive here. This all are positive. At starting, all are positive, right? There is no negative value at starting. All are positive, and so all are positive, and total number of elements is 5. So the count is 5. So if count is 5, we can't make pair for all of the elements, so I need to skip one of element. So whom I skip? I will skip the element which is minimum, whose difference is minimum, whose difference is minimum. Why? Because if the difference is minimum, it means after taking XOR, this value is not much greater than the current value. So I will take whose difference is minimum. I will skip that element, right? So while storing, while summation, while taking this a's or k minus a b's or k, I will make a variable and maintain a minimum value among all of them. If the values are all positive, if the values are all positive, this is for if the values are all positive, then we are we are maintaining the value minimum value among them for among them, right? So that in odd case I can remove that element, right? But what if there are negative element also present? What if there are positive and negative elements are present? So if there are also negative element present, if you see here in this question, so for positive elements I need to take a minimum value among them, but for negative values, what I need to take? So if the negative value is present, and after differentiating it, it will give me negative values, right? So I need to take the maximum negative values which is present, so that I can add in my answer, so that the it can give me the maximum possible sum. Have you understood? So suppose let's example, the same example which we are referring to this. Let's take this example, right? Let's take this example. So suppose here a b c d e f, and suppose this is less than 0, this is less than 0, and others are greater than 0. Others are greater than 0. So initially I have stored all the summation values which are present initially in my answer. So this is included in my answer. This is included in my answer. A, B, C, D, F. So for, if there are even number of counts, even number of counts of what greater than 0 values, because the less than values are still not be recovered. So I will count only the even number of I will count only the greater than 0 values. So how many greater than value is there? 1, 2, 3, 4. This There are 4 elements which are have greater than 0. So if count is 4, it means it is even. So I can take all the values here, because we can values here, because we can form the pair. We can form the pair. But for even case, for odd case, suppose this is not given here, so there are only 3 pairs. So this count is odd now. So now I need to either remove this any of the positive elements, or either I can include any of this negative elements. Understood? I i i need to make a pair, na. I need to make a pair. So if the total count is 3, so either I can add one node, or either I can remove one node. So if count is odd, then I have two options. I have two options. Either I add a node, or I remove a node. Remove a node. So if I need to add a node, what will I need add? So if I need to add a node, I will add the maximum possible negative values, because that will give me then if I add the maximum negative values, it means that will give me a positive maximum possible sum, right? And if I need to remove a node, what will I remove? I will remove the minimum positive values among them. Positive value among them, among the positive differences. Understood? And if I need to add, I will add the maximum negative among the negative differences. Among the negative differences, right? So this is how we can form the pair if the element is odd, right? And we can take the maximum of both of them after adding, right? So suppose here initially we have given ab plus b plus c d f, and I have these three. So after adding, so this two, suppose in this positive elements, the minimum elements is c zor k minus c. C zor k minus c. And in this, the maximum in between the negative elements, the max element is c e zor k, minus c, right? Suppose this is the max and the minimum. So I have to already included this three part. I have already included this three in my answer: a zor k minus a, b zor k minus b, z zor k minus c. And for removing, so I have already included c zor k minus c, but I need to remove. I either I need to remove a node, or either add a node. So I will remove a node of positive value. So if this is a minimum value, so I need to remove it. So for that, I need to minus it from it. So what I can do is either I can remove this minus m, or either I can add this max value to make pair. So I need to take the max of both, because I don't know na कि after adding or after negative negation, which is the maximum. So I need to take both of the cases and take the maximum of this, and this will be the my final answer. My final answer. So if you see here, what I am doing here, I need to take two variables to maintain the minimum of positive differences was minimum among positive differences and maximum among the negative differences. This I need to maintain two variables. And the problem was and wills, so that I need to don't need to short it by storing it, right? So that's how I can save space and time both. So let's see how will I implement this, then you will get more clear about this, right? So let's start. So this is, there is no need of this vector now. I started I have taken a mean and the max value. So the mean value started from int max and this max value int mean, right? Now the value get operations on this num size or k. I will store initial values at the starting point. Every initial value is 0. If you have seen here a b c d f, this values, this values a b c d f, all the values in starting point. So this is for the initial starting point, we have stored all this. So if this value is greater than num size, it means it is after operation it will give me a positive value, so I will include this in my answer. But I will also fi- uh, maintain a track of the minimum value which in the positive values, so I will maintain a track. And if the value is greater than num size, it means I need to make a pair for this, so I will also count this, at how many values are greater than num size, so I will also count this, so that I can at last I can see that whether the total number of count is even or odd. So and according to that I will add a node or remove a node if it is odd. Otherwise, if it is even, it means all the I can make all the pairs and I will simply return the answer, right? So that's why I'm maintaining a count for that. And if value is less than num size after taking XOR, it means it is a negative value, so I don't need this. But if the count is odd, I need to take a extra node. For that I need to take a maximum maintain a max value, so that I can add this if we need at last value, so I will maintain a max value for that, right? Now I will check after all this operation whether this count has even number or odd numbers. And if it is odd, it means I have two cases: either I can remove a node from positive values, or either I can take a node from negative values. So if I want to remove a node from positive value, so I need to minus it, because I have already included in my answer, so I need to minus it. And if I want to add an extra node, so I need to add a max value and take both of the max values and return it. Otherwise, if cn count is even, I will simply return answer, because I can take all the positive changes here, right? So this is how we will solve the problem, and this will give us the time complexity of n and the space complexity of O1, because we haven't taken any extra array. So this is the this is how we will solve this problem from O of n log n to O of n. So yeah, this is how we will solve the problem. So it this question is of tree, but the trick was here that this question of tree was concluded to a array questions, right? And how we will see that, we see using the XOR properties, this four XOR properties. And by analyzing this graph, that how these edges are moving, we can see that we can choose any pair in any in tree, we can choose any pair of nodes and make that pair depends on how this value get increase or decrease, right? If the value get increase, we will include in my answer. Otherwise, we will include whenever the count of pairs is odd, whenever the count of elements is odd, right? So this is how we will solve this problem. So it takes a lot of efforts, because I have already made this video 1 hour video before that, and after this all operations the video got crashed before uploading, so I need to make another video for that. So yeah, thank you. Hope you have understood. The trick part is here only, that this tree part is converted to array part. Now the question is of array and the XOR properties which we have seen here, right? Hope you understand. Thank you. Bye bye.